Hello everyone, my name is Eevi-Inkeri Forsman. I'm a senior data engineer at Zalando. Here I have my colleague with me.
I'm Rosmy Sebastian. I'm a senior product analyst in Zalando.
Today we're going to talk about how different data roles work together in Zalando when there are so many that we were having a hard time even naming. So how are we all delivering value with data? Here we have our content for our talk today. So we're going to quickly go through all the data roles in Zalando. Then I will be presenting what is it that I actually do as a data engineer. And then Rosmy will go through the product analytics part. And then we wanted to contribute to the sustainability theme of this talk. And we're going to provide a couple of real-life data examples, how we are building a more sustainable future for the fashion industry. I'm sure there's no one in the audience who doesn't know what Zalando is, but we are an online store selling shoes and clothing and beauty products. Zalando was started in 2008 when Robert and David were selling flip-flops in Berlin from their own apartments. And today we are serving around 62 million customers. So let's get started with the data roles. Here we have the data roles in Zalando. If you're wondering about the different data professionals you might see in the job market, it's no wonder you might be a bit confused, since even in one company you can have so many. We tried to simplify this a bit by grouping them into 3 groups. The data engineers are architecting and building the pipelines that make the data flow. Analysts are the ones who interpret the data and support business decisions. They identify patterns and present insights with reports and dashboards. Then we have the data scientists who take the analysis a bit further by using machine learning models or statistical models to predict future trends or build recommendation systems and personalization features. Then let's go into our own roles. So what is it that I actually do? At its core, data engineering is moving data from place A to place B and maybe doing some transformations on the way. To my non-techie friends, I explain that I'm like a plumber for computers. That makes it easy for them to understand when I'm telling them I'm fixing a broken pipeline. To my more techie friends, they understand that I write Python or SQL, but actually writing scripts for moving data is not the majority of my job. I actually have to do this kind of a balancing act with different trade-offs, and that's what I'm gonna go through now. So now that we have cloud storage, we can buy more space for our photos with just one click. And when you're working with data lakes and data warehouses, you don't even have to click. The storage will expand almost indefinitely. This will obviously produce costs and also at some point affect performance. So we might need the data all the way from 2008 when we're building prediction models. But do you really need to see the whole picture in a dashboard as a line? Probably not. So we have to balance out which kind of data do we serve from a quick access layer and which kind of data do we store in a more low-cost archive. Automating pipelines is something that I think everyone understands that data engineers are doing. So we usually start with a need. Some data needs to be somewhere, but how often? Usually people like to think about real-time data, that it's the good choice, but well, just building a pipeline and letting it run is like a dream. pipelines do break. You can't just write and forget. So APIs go down, servers crash, credentials need to be renewed. That's where the word robust comes in. So your data pipeline needs to survive failures, increases in the data volume. It should be able to automatically retry when it first fails. It needs to be idempotent, which means that you can run the process again with the same results. You need to have data quality checks. So your pipeline may succeed perfectly and just produce nulls. Then again, you need also monitoring because you want to be the first to know when those nulls appear and not CEO, who's, Robert, still gets the dashboard. So whenever we have a data load that runs daily, it's used, and you do need to do some maintenance, you have the whole day to do the maintenance and then wait for the next day's run. But if you have a near real-time pipeline, that's like fixing a car when it's running on the highway. So it sounds nice, but not to the data engineer. Then we have cloud compute. Today, it's very easy to fix a performance issue by throwing money at it, which obviously in the long run is not very good for the business. So my job is to find the sweet spot. When to use a bigger machine and run it faster, when to use a smaller, like when we have nightly runs. Sometimes bigger isn't actually always cheaper. More expensive, because if you can take a machine that's double the cost but runs in less than half the time, then actually it's cheaper per run. So it really is a balancing act. We can also improve compute cost by optimizing the code. So maybe in the beginning, you first overlooked your heavy joins and early filtering. But then again, you also need to remember that you, in fact, are a cost. So if you spend days optimizing your query and then save some cents, which point will it be profitable for the company? Then we have security. This is probably the most important part, but also a thankless job. So if you do your job well, no one notices. If you don't do it well, you will make headlines. So I believe in the data democratization. Data should be available for everyone, so it should be shared at a right-to-know basis, not a need-to-know basis. But then again, we have to obey law and regulations when using personalized data, or we don't want that non-public information gets out of the company walls. So again, balancing with the sensitive and the non-sensitive. Then there's our customers. Our customers are usually business units that require some kind of insights. Sometimes those business units have overlapping needs, and maybe they just didn't check with each other before asking us. So too often it's the data engineering team who notices that, hey, this probably already kind of exists. Maybe we can expand, or see the needs and feel like a deja vu experience. So when to build new, when to scale the old? Do we build fast solutions, or do we make sure that we are building a sustainable data platform? So what I want you to take from here is that writing Python and SQL is not enough for a data engineer. You also need to understand software principles like compute and networking. You have to know the laws and the regulations around data. And if you really want to be a successful data engineer, you need to understand also the business needs. So build systems that endure time, learn to say no, or you're the one feeling the pain. Now I'm ready to hear from Rosmy.
We have just heard how our data engineer performs the incredible feat of turning a chaotic sea of information to robust, high-performing pipelines. But here is the reality, that data, as massive and sophisticated as it is essentially a frozen potential. It has no real value to anyone until it is being used to drive the strategic goals. And that is where the product analyst in Zalando comes in. So we act as a bridge between the raw data and business goals. We are embedded into a product team, which consists of a product manager, designer, and engineers. And we work across the whole product life cycle, from the first what if in the discovery phase to the launch. We do experimentations and impact analysis to ensure that every feature is validated through evidence rather than just intuitions. So our mission as a product analyst is taking the maybe out of the innovation and replacing it with a why. So at Zalando, we don't just build product, we evolve product by a process called product development process, or PDP as we call it. It has 5 phases, and in all the phases, product analysts contribute. For example, in the first phase, where we are looking at the opportunity or discovery, we act as a detective to understand from data what is the size of the price, so that our teams can actually prioritize problems that truly move the needles. And in the second phase, we try to build a KPI framework to understand how we can measure the success of a product. This is using by identifying the North Star metrics to signal success, and also the guardrail metrics as a safety net. Then we do experimentation to understand if our feature is the one that is actually driving the results and not some random market events. So for this, during the MVP or during the pilot phase itself, we start introducing experimentation like A/B testing or quasi-experimentation. Now, our role doesn't stop there. Once the product is launched, and from MVP to post-launch, we actually actively monitor the performance of the product so that we are able to make changes as we go. And the last phase is where we close the loop. So product analysts act as a feedback provides a feedback to the product teams to improve or predict the future of the feature. So what we do is we recommend, based on our analysis, whether we should double down on a product which is a success, or we should pivot based on our findings, or we should actually just kill it because it doesn't provide the value we thought it would. And this slide actually summarizes everything we mentioned here. So we have the engineer, who is the architect, who build actionable pipelines and robust pipelines, analyst who act as a visionary, who provides insights about the product, and data scientists who build predictive models and algorithms. Although we use the same tools or technical toolboxes, we just differ.
And brands that we work with who sell their items on our platform. I work in pre-purchase data, so that means all the things that are happening before you make it to checkout. So product info, pricing, stock. So how can we reduce the returns even before the purchase is made? Here we have the 3 main drivers for return rate for pre-purchase. First one is article information. So the data scientists have identified certain high-value attributes that if a t-shirt has a neckline description or an ankle boot has a platform height, it will most likely be sold and also not to be returned. So this is like a nice example on where we really need the data. It's crucial for our business. No human could come up with this thing. So we list the products and the attributes and share it with the partners so they can send us more information. Second one is low quality images. So PDP, or a product description page, is the page that you see when you open a product in Zalando. So you have the picture and the attributes. Elevated PDP is a PDP that has video or lifestyle images, and those pages tend to have twice more views and less returns. And for some reason, this is extremely important in shoes. Then we have poor size guidance. So brands have very different sizes. For instance, me, I am a medium in some stores. I am an extra large in some stores. And in some stores, it's forget about it. So this is important, especially in online sales, because we don't want customers that they have to order 3 sizes just to get the right one. So we have this, if you've ordered several times from us, you probably already get this label when you choose a size in Zalando store. It states something like, this item runs small, we recommend sizing up banner. Now this data we actually get from the returns you make. So when you cross the box that this item was too large or too small, we will take that into account when we do the recommendations. Here's how different data rows are included in the size and fit project. So as data engineers, we gather all the relevant data that is needed and create a data product that is easily ingestible and used by the analysts. Then the data scientists build the predictive models and algorithms to create the recommendations. And then there's product analyst. And well, actually, since I have a professional here, I might just give this one to Rosmy.
So as a product analyst, we ensure that the feature actually drives the sustainability goals by tracking our return behavior. So we were able to actually reduce our size-related returns by 8%, proving that our precision of the model is not just good for sales, but it's also good for more sustainable fashion industry. Going to our next project, we have something called EPR, which can be also said as extended product responsibility. So most circular economy projects rely on the hope that people will do the right thing. In the past, our responsibilities end when the customer clicks buy. But in the world of EPR, our relationship with the product is much like a lifetime commitment. Under this framework, the manufacturers, importers, and retailers like Zalando aren't just responsible for buying or selling items. We are now legally responsible for what happens when they are worn out, discarded, or recycled. So it's like literally putting a price tag on the environment. And it drives sustainability as not just a nice-to-have slogan, but a financial metrics that lives in our database. So from a take, make, waste model, we go into a circular economy where a better design leads to lower environmental fees. It's the first law that makes sustainability cheaper than being wasteful. But in order to actually enable this EPR, we need a data thread that follows the product from supplier, factory, customer to recycler. So that is where the data engineers and data product analysts come in. So data engineer creates a digital traceability for the product by connecting supplier data to our smart product platforms. And the product analyst, we check the accuracy of the data and the impact on profitability and sustainability. And we also identify high-risk categories for which the data is missing and hence blocked. This is the last slide we have. To wrap everything up, this slide can be seen as a blueprint of a data-driven factory at Zalando. So our engineers are the architects who are building this massive conveyor belts that moves millions of data points reliably. And then we have analytical engineer, who is like a hybrid of both of us, like a data engineer and analytics. He actually does a messy raw material. He takes all the messy raw materials and refines them into tested components like an engine or a steering wheel. The data scientist is the R&D specialist, like building the smart tech, like a self-driving car, for example. So that allows us to make intelligent decisions. Product analysts, like us, are the performance test drivers. We monitor the KPIs and provide insights to navigate the business goal, like how do we get the 13% sales increase, or the engine is overheating, let's do something about this. So separately, these are just roles, but together, They form the high-tech factory that drives Zalando towards a sustainable and data-driven future. Thank you for having us, and have a nice weekend.